Today we're looking at independent and dependent events. So please copy down the standard benchmark indicator at the top of your math notebook. The student will predict the probability of outcomes of compound experiments and do the experiment. You can pause the video here to give yourself time to write down the SBI. Compound events, probability word problems, dependent and independent events. Independent events are two events, like rolling a die and flipping a coin, where the outcome of the first event doesn't affect the second event at all. If I roll and get a 5 on the die, it's not going to affect whether I get a heads or a tail on the coin. Dependent events are connected. What happens with the first event determines the probability of the second event happening. So we're going to walk through some examples here so you can see how that works. So for question 1 here, the names of 7 boys and 10 girls from your class are put in a hat. What is the probability that the first 2 names chosen will both be boys? So first, we know we have 7 boys out of the 17 kids in the class. So that's the probability of a boy being chosen first. Then we're going to multiply it by the second event. What's the chance that a boy will be chosen second? Now, we're not putting the names back into the hat, so now our probability has decreased. Now we only have 6 boys' names in there out of 16 slips. So we're going to multiply by that. Then we're going to multiply across, just like we do with fraction multiplication. 7 times 6 is 42. And then we're going to multiply 17 times 16. Which gets us 272. Which, since both numbers are even, we know can be simplified, so we're going to divide the top and the bottom by 2, and we're going to get 21 over 136. So the probability that a boy's name will be chosen for the first 2 names pulled is 21 over 136. For problem 2, your drawer contains 11 red socks and 7 blue socks. It's too dark to see which are which, but you grab 2 anyway. What is the probability that both socks are blue? So the first thing, we know we have 7 of the socks are blue out of 18 total socks. So now we've pulled 1 sock out. Now we want to see what's the probability that the next sock we're going to pull out is also blue. So now we only have 6 socks out of 17 possible socks. So 7 times 6 is 42. And then we're going to multiply 18 by 17. Which gets us 306. Both numbers can be divided by 6, so we get 7 over 51. Number 3, an animal cage is holding 9 black cats and 4 white cats. None of them want to be in there. The cage door is open slightly and 2 cats escape. What is the probability that one of each color escapes? So if we go with the black cats, because they're most of them, so we'll start with them, 9 out of 13 of the cats are black. So 1 black one escapes, and then we want a white cat to be the next one, so it becomes 4/12. Then we're going to multiply across, so 9 times 4 is 36. and then we're going to multiply 13 by 12. Which gets us 156. Then we can divide both of them by 12, and we get 3/13. Four, a box contains 8 red marbles, 7 yellow marbles, and 10 orange marbles. If you pick 2 without looking, what is the probability both will be yellow? So we start with 7 yellow marbles out of 25 marbles. Then it's going to drop down to 6 yellow marbles out of 24 marbles. To make this easier for ourselves, we can simplify the 6/24 now rather than at the end. So it becomes 1/4. Which equals 7 over 100. And then we don't have to go through the long simplifying process at the end. Please copy down all of this work and glue it in your math notebook.